thank you guys for joining us for our first official engineering AMA from the team. We have Joshua and Max, who you know. We also have JCV and Antonio. I really don't bring a lot to the table in this, so I'm going to immediately turn it over to Max and team, and I'll ask some questions when they tell me to. Thank you.
Awesome. Sounds like a plan. Appreciate it. Yeah, so welcome everyone to the Protocol Engineering AMA. So at Hemi, we have two engineering teams. Obviously, there's a lot of working together and crossover, but we have the Protocol Engineering team who's mainly focused on, as the name would suggest, the protocol. So anything, HVM, daemons, pop mining, consensus, BitVM stuff. And then we have the apps team who does all the UI, all the front end. They do a lot of stuff behind the scenes as well that either percolates up to UIs, all kinds of backends, all kinds of tools. They maintain the Explorer. So this is an AMA with the protocol team. So if you have any questions about the UI or whatever, that's these aren't quite the people for it. But anything about the protocol, anything about the design, security, features, how HVM works, HBK, any of that. This is the team who built it, and so we're looking forward to answering some questions. I think before we jump into that, if we want to just go around the table and each of the engineers here, if they want to introduce themselves and talk about what they're working on and anything else interesting they want to add. So I'll kick it over to JCV first.
Alrighty, yeah. So, hi, I'm John, or JCV. I just do a variety of things in the protocol engineering. A lot of just herding cats. I spend a lot of my effort on the ability for people to run nodes. So if there's a terrible shell script, I'm probably largely responsible for it, along with paying attention to security bits and starting to look into some of the BitVM stuff with Max. And yeah, just been in this space forever. One of the authors of BTCD, so long time Bitcoin person, and I guess probably largely known to the community for putting out a 3D model of a Hemi Christmas ornament. And with that, I can pass it over to Joshua.
Hello. I'm Joshua. I am a software engineer on the protocol engineering team. I primarily spend my time working on various daemons in the Hemi network repository, infrastructure-related stuff, and security stuff for Hemi. I'm usually on most of the AMAs, but I am actually an engineer. Rick's the community guy. I'll hand it over to Antonio.
Hello, I'm Antonio, or Antonio, if you can pronounce that. I'm the newest member of the protocol engineering team, and mostly I also work on the Hemi network repo that deals with the core daemons of the Hemi network, jumping around between a lot of tasks, but I'd say most recently my focus has been on reworking some of the daemons we have, namely BFG, as Marco, who couldn't be here, would say, kind of dealing with the tech debt that we have on that and trimming stuff down a little bit.
Awesome. And thanks everyone for introducing yourselves. And then I'll go through very quickly just some of the items that the protocol engineering team is working on. So if anything sparks anything people want to know more about or dig into, and also give kind of more of a perhaps detailed roadmap, at least from the technical perspective, versus what we usually go over with on Midweek with Max. So a lot of items in the work stream. Obviously, there's some technical components for the token that are being worked on. There's a contract that's been shipped off to auditors. And so there's some limited work there. A lot of the team's primary focus right now is on a couple different streams. So we have a refactor of all of the daemons in the Hemi ecosystem and how they talk to each other. So being able to separate out, BFG from BSS, from opnode and opgeth, being able to run some of those components independently We're already part of the way there with the local node scripts we have that I mentioned on Midweek with Max, where you can go and you can run different setups to some of those nodes for different use cases. Like you can run everything, which includes Bitcoin and Ethereum L1 full nodes, all the way down to a minimal version, which is just opnode, opgeth, and BSS. And so we're working to further improve that system, basically letting somebody run, TBC, which is the Bitcoin daemon that we have embedded in opgeth, being able to run that as a independent Bitcoin full node, being able to use that with a pop miner, being able to make BFG, whose real intention in the stack, and it kind of grew into something else, making BFG purely about Bitcoin finality and being able to run independently and connect to either a third-party Bitcoin RPC endpoint or one you run locally, whether that's TBC or Bitcoin D, and extract out everything needed to generate Bitcoin finality information from pop mining. And so just giving people ways to run different parts of the stack in different configurations that are minimal and have the smallest possible footprint while supporting a certain feature set. So for example, a payment processor may be totally fine using a public Geth RPC endpoint, but they want to run their own BFG node to have ironclad Bitcoin finality information from something that they're running locally, and there's no trust assumptions. So a lot of things like that, different configurations that different people, whether you're running a Explorer or a DApp or MetaMask and you just really want to run your own node, or you want to run your own pop miner that doesn't rely on any infrastructure we run, things like that. Trying to make that easier and trying to add more features to the stack that enable some cool use cases. So that's one of the major threads. Another one right now that's relevant is the Pectra rebase. So there's some features in Pectra that are applicable and useful in the L2 ecosystem. So some of them are just things on the base layer that are nice to have, but there's really no technical work. Like they're increasing the number of blobs you can have, which makes L2 transactions, L2 DA cheaper. But there's also some stuff with account abstraction that will be useful for one of our partner projects. Probably more info and more announcements on that soon. But so we're doing a rebase basically to support the new Pectra features that are relevant to L2, get up to date with some of the recent optimism improvements, and obviously make sure those are integrated with all of our HVM changes, all of our POP changes. Another big thread that's ongoing is working on ZK provability and BitVM. So basically getting the stack to be able to settle to Ethereum using zero-knowledge proofs, so faster settlement, more secure settlement, and then we'll have a fallback to optimistic proofs as a backup, so you get the best of both worlds in a lot of senses. And then that ZK provability also lets us build out BitVM tunnels, which are a more secure, more capital-efficient way of custodying Bitcoin on behalf of the protocol for the Hemi Bitcoin tunnel. And looking a little further out, one of the work streams that's going to be started in the future is decentralizing the sequencer. We're going to be using more than likely, like 95%, likely a Ethereum proof-of-stake variant. So one of the benefits with proof-of-proof is since we're getting Bitcoin finality, it gives us a little more flexibility in the underlying consensus protocol that we use. And so you look at a lot of L2s and even beyond the L2 ecosystem, what L2s are building towards, but also what, chains in the Cosmos ecosystem, whether you want to call those L2s or not, it's a technical discussion, but, the Cosmos ecosystem or, Polkadot or some of these independent L1s, a lot of them are moving towards basically security, quote unquote, security preserving chain consensus protocols, which are there's something called the CAP theorem in computer science, which is for consensus protocols that says you can't, boiling it down, you can't have a protocol that can survive, that can be both always online and always secure and never have, a fork or never revert state. And so every consensus protocol is a trade-off of those two. And Ethereum proof of stake does that in a very interesting way. They optimize for liveness, which means if there is a consensus fork, the protocol can recover and survive that. The alternative is things like what I think is now called Ignite, what used to be the consensus protocol used by Cosmos and all those chains. They focus on quote unquote security, which basically means it boils down to the chain will never fork. So if there is a fork, the chain will halt. And so given that we get Bitcoin finality using proof of proof, that lets us go and use a liveness preserving protocol like Ethereum that can survive forks while still giving Bitcoin finality for people who need it. So if you need ironclad finality, you can wait for Bitcoin finality. but we get all the benefits of a liveness preserving protocol. So if there is a consensus split or something of that nature, the network will be able to recover from that, which is a very cool feature. And, Ethereum can do that obviously because they're extremely secure with all of the ether that's staked in their consensus protocol, but it's harder for smaller chains to use those types of protocols. And that's why having Bitcoin there gives us that extra edge to be able to use that protocol while still maintaining security for people who need that ironclad finality. We're also looking at, as part of that, using single slot finality, which is something that's been going around in the Ethereum research community for a couple of years. And it's basically a way to, the way Ethereum currently works is you have all these different nodes and they all, somebody makes a block, but then all the other participants basically sign off in that block and say, yep, we agree that this is the current block. And if we, sign a conflicting message, we would also get slashed to some extent. And so you get this moving finality or moving economic finality that due to network delays and stuff of that nature is around 7 minutes. And with single slot finality, you're able to use some interesting signature aggregation methods and things of that nature to achieve that a lot quicker. And so it's not something that's live on Ethereum today, but we are looking at adapting a version of that as well to the variant of Ethereum proof of stake we're going to be implementing. And beyond that, there's also going to be eventually a track for more HVM features. So adding stuff around meta protocols, adding stuff, meta protocols being like your BRC20s, runes, ordinals, things like that, adding a native support for those in the indexer, and then also adding in support for what we're calling Bitcoin event-driven behavior. So being able to say, rather than needing an EOA to still initiate a transaction, even though all the Bitcoin data is inside HVM, being able to say, hey, when this action occurs on Bitcoin, when this UTXO is spent, when this transaction appears, when a block appears without this transaction, whatever, then trigger a transaction with gas that's already been pre-purchased from the protocol, run this transaction. So it makes building some sorts of Bitcoin infrastructure a little easier and a little more reliable if you don't have a big network of incentivized EOAs monitoring for certain activities. And then super long term will be Chain Builder. Chain Builder is going to be our L3 plus ecosystem. So being able to launch a chain that runs as an L3 on top of Hemi. It has, optionally if you want it, has HVM. Optionally if you want it, has proof of proof. We expect most people launching an L3 in our ecosystem would want both those features, and they'd come in sort of the standard default package. And then you're basically getting Bitcoin security at a very low cost because Hemi can act as a security aggregation layer. So you have 100 chains that pop mine to Hemi, and then Hemi pop mines to Bitcoin. All those publications from those chains to Hemi is very, very cheap because you're not publishing directly to Bitcoin, and then all of that's getting, in a sense, rolled up to Bitcoin, and then all those chains have mutual Bitcoin finality. So chain A knows what block on chain B's Bitcoin final, so it can use that for processing super secure cross-chain messages, obviously with a delay because you're waiting for Bitcoin finality, but if you're writing an application that needs that enhanced security. And then also those L3s, as with L3s in any ecosystem, they would have access to all the assets and liquidity basically on the L2. So being able to access both everything tunneled over from Bitcoin, tunneled over from Ethereum, being able to do cross-chain calls back to Ethereum through Hemi, and being able to interact with existing liquidity that's on the Hemi network. And then kind of phase 2 of that chain builder system is a shared sequencing, shared DA or data availability system that offers more ecosystem cohesion. So if you have a lot of chains that all use a shared sequencer and they use a shared DA system, there's a lot of things you can do for interoperability faster or more secure that are interesting. So that's kind of the V2 of chain builder. So that's, I think, a pretty comprehensive protocol roadmap of what we're working on now, what we're going to be working on in the future. And if anyone wants to ask any questions about any part of that, we have a big part of the protocol engineering team here to talk about it. So with that, I'll pass it back to Ray. Oh, go ahead.
Wait, I wanted to add one thing that for Chain Builder that I think you undersold a little. When you said that you could get Bitcoin security at a low cost, it's important that the cost is not just the on-chain cost. It's, building Hemi, that was a pretty major undertaking, including the Bitcoin finality parts of it. Part of the point of Chain Builder is not only is it cheap on-chain, but your cost to actually make this L3, you don't have all of the, insane mess of stuff that we had to build to get that Bitcoin, to get yourself locked into Bitcoin. the people building the chain get that much cheaper too.
Yeah, it's a really good point. And the same applies to HVM, all the R&D, all the hard work that went into integrating a Bitcoin node into an EVM. If you're launching a chain builder chain, you're getting all of that as well as just part of the default configuration. And so we'll be supporting other configurations. If you want to run a SVM, you may have to do some custom development, but it works. It can settle back to the protocol, the L2 protocol layer. It'll be flexible, but that default package has all of this, R&D that we put into making Hemi really feature rich for both Bitcoin and Ethereum dApps. You'll have all that natively in the L3 if you want it, which is pretty cool. Cool. With that, I will throw it back to Rick for going through any questions. And then if anyone has any other questions, feel free to post them in the chat as well.
Sounds good, Max. Actually, before we go to questions, I know JCV had a quick update of something we were working on, but Max, I believe you did as well.
Oh yeah, sorry, totally forgot. We finally got the testnet pop points up. They're up on the testnet pop stats dashboard. I'll send the URL for anyone who's not seen it or has lost it in the last couple months. So you can look up your primary EVM address there, and you'll see all of the addresses that are linked in Absinthe to it. Or you can look up a secondary address and it'll route you to the primary address that it's linked to. So if you look up any address there, you will see all of the pop points that you earned from that deduplication process we talked about. So taking basically all the pop transactions and all the keystones that those mined, and then treating them as if they had all been done by the same address, and then running the pop payouts calculation algorithm on that. So that applies both to bonuses and to the daily activity pop points. So for example, if you had two EVM addresses that were also pop miners and they're linked together, doesn't matter which one's primary or secondary, and say one of them did 3,000 pop transactions, the other one did 2,000. If those were all pop transactions mining distinct keystones, so there was 5,000 total unique keystones between them, you get, for example, that 5,000 keystone bonus, and that would be credited to your primary address. So basically, it's the same thing as before, except everything is based on the primary EVM address, and then any secondary addresses you had linked to Absinthe before the cutoff period, any pop activity under those is treated as if it was also part of the primary. And if you didn't do pop mining on the primary, that's fine. Then the primary is treated just as if it had done all the pop activity of all the secondary linked addresses. So everything should be there, should be final. Obviously, if there's any mistakes that come up, we'll correct them and figure it out. But we've gone through and done a high-level audit, and everything looks good. So that's up, and then those points will be posted to Absinthe soon, as in, next couple of hours more than likely. But you can go to that site now and see, with your primary or looking up one of your secondary addresses, what the end result of that full deduplication got you as far as points, as far as what bonuses and the daily breakdown and all that. So that is finally done.
That's awesome. And Joshua and I will put out an announcement to ping everyone regarding that, just so everyone can link back to it. John, did you want to talk about the other engineering initiative we have?
Yes, absolutely.
All right, get him, bud.
So, when we first started Hemi, one of the core things that we cared about, even before Hemi was called Hemi, and you don't get to hear the alternative name, sorry, but from that very beginning, we wanted Hemi to be a place for builders. There's not just, we obviously depend very heavily on all of the DeFi projects that get added to Hemi, all of the existing things, but we also want people to build things on Hemi. As a firm believer that the best thing to come out of, blockchains or cryptocurrencies or anything hasn't been built yet. And realistically, is not going to be built by us, the core team, because we're so busy building, the core stuff that you people can build with. We want this to be a place for builders. And so basically the initiative that Rick was talking about is we will have a builders channel. Exact name of it, I think Rick or Joshua might have a better name than that. But we basically will have a semi-private channel for builders, which for people who want to build stuff on Hemi to give you more direct access to the people who build Hemi and who know, both what things you're going through, what problems you might have, and what the sort of shortest path from where you are to you actually building something great on Hemi. And yeah, Joshua and Rick will be able to provide details for how on Discord you'll be able to qualify for that channel. But if you're thinking of building something on Hemi, the time is coming that you should start, and you should get in on, this channel so that you have, are in the best place to do it. Because remember, the best things that'll be built on Hemi could very likely, hopefully, be built by either someone here or someone who watches this later, or, someone who is not in the core team. Because we're busy enough as is.
Awesome. Thank you, John. I believe we were just going to call it the Builders channel. So you were kind of spot on with that. Regarding details, I'll circle back with both Joshua and John, and we'll get an announcement regarding that as soon as possible. There will be some criteria to get access to the channel, as it's going to have team/engineering access, so you can ask questions, further develop your project. So it's not going to be completely public, but given the criteria, people who are serious about building on Hemi can totally do that.
Yeah, we want to be inclusive. It's not public, but at the same time, it's pretty inclusive. We're not, there's not going to be something absurd to get in there. And so it sounds like, Rick, the channel naming was basically the way the naming for Poochie went on The Simpsons.
Basically.
Okay.
Basically. Yeah. Yeah, spot on. Everyone okay with Poochie? Yeah, basically. So let's see. Okay. So on to questions. Okay. Can you provide some insights about the handling of Hemi BTC? How do you make sure the underlying BTC is stored in a secure way?
Yeah, good question. So there's a couple different phases to the Bitcoin tunnel design, like I talked about earlier. The BitVM one is in development, and that'll be very secure. We can get into the details of what that means. I think there might be a later question about that. The current design is based on over-collateralized vaults. So basically, anyone can run a vault. We'll be posting instructions on how to do that soon. We're working on trying to get some TVL partners to run additional vaults as well for early decentralization. But basically, anyone can post collateral and then go run a vault. So you put up $100,000 of USDC or ETH or any of the supported assets. It can't be some hyper volatile asset, but there's a whitelisted set right now. It's USDC, USDT, and ETH, I believe, or wrapped ETH. So you post that collateral, and then you're allowed to custody up to 70% of that collateral value on behalf of the protocol. So people can deposit that Bitcoin to that vault. And if it gets over 90% over collateralization, so say people deposit at 70%, and then the value of collateral between those deposits up to 70% drops by 20%. So you put in $100,000 of USDC, but then Bitcoin goes up 20%, for example, now you're at 90%. Then the protocol will liquidate, or people can use the protocol to liquidate your vault and basically keep the system solvent. And so that's basically the economic security side of it. And then there's the key security side of it. So we'll be, again, releasing info on how to run vaults yourselves soon. It's going to be an iterative process of adding more modules, but the end goal would be having modules where people running vaults can run very distributed systems. So even if one of their boxes gets hacked, they could have multiple different boxes that are each signing with an algorithm like Frost that basically splits a key or shards of a key across multiple machines, and you could run all those machines with different configurations. So that's the security on the vault operator side against somebody hacking into their system, stealing the Bitcoin, and then them getting liquidated for the protocol. So 2 parts to it. Economic security is the collateralization and liquidation procedure, and then actual key security will be different key security modules that people can use, and that's going to evolve over time.
All right, thank you. Will Capsule continue to be supported and maintained on Hemi mainnet? Currently, we are unable to create capsules on mainnet.
It will be. Getting that spun up's been lower priority than a lot of the other post mainnet stuff, like getting partners running nodes, getting DApp protocol developers onboarded and everything working and infrastructure improvements, but that is definitely something we'll be standing up on mainnet at some point, hopefully in the near future, but lower priority than a few of the other things that the team's working on.
All right. We have a lot of good questions, but I have to be perfectly honest. This might be my favorite. Can you explain pop mining to me like I'm 5?
Let me take a stab at it. Maybe someone on one of the other engineers is better at some of the simpler explanations, but basically you can think of Bitcoin like a immutable I don't know, this immutable system where every 10 minutes anything that anyone gets into Bitcoin will never be changed. And obviously Bitcoin can be reworked or whatever, but high level, once something's in Bitcoin, it's going to stay in Bitcoin. And so people use that in a lot of different ways. So for example, say you had a legal document that you wanted to memorialize that this was the official version and it looked like this at this point in time. You could take some digital fingerprint representation of that. Think of it kind of just like a picture of it in some way, but it's this cryptographic picture where if any letter on that page changes, then this cryptographic fingerprint changes. And you could put that in Bitcoin. And then since Bitcoin is this great immutability layer, once it's on Bitcoin, nobody can change it. And so in 2 years in, court, you could pull up this Bitcoin proof you have for this legal document and say, hey, here's my proof that this document looked like this at this point in time. This is what we signed. And, the version that this other person is presenting is clearly manipulated. And so taking that same idea and applying it to another blockchain, so say Hemi, for example, Hemi is also, just like you can take a fingerprint of a digital document, you can take a fingerprint of an entire blockchain. And so what pop miners are doing is they're basically taking snapshots at points in time of what the entire Hemi chain looks like, which is summarized as essentially the header, the latest header from the Hemi network. And they're publishing that to Bitcoin into that immutability layer so that it can't be changed. And so then when the Hemi protocol determines what state of Hemi is actually correct, it references those fingerprints that people previously posted of Hemi to Bitcoin. It references those and says, this is what Hemi looked like at this point in time. Therefore, we know that is the correct state of Hemi at that point. So somebody's proposing a different state of Hemi, a la, quote unquote, a different contract in the failing metaphor that I'm using here, then the protocol can identify that as incorrect because it's referencing Bitcoin as this universal source of truth. And there's a lot more complexity in that for what happens if people publish two competing versions. And so there's fork resolution and there's things based on when they got into Bitcoin, and there's ways to validate that supposed publications of Hemi are actually valid Hemi states that even mean anything. So there's more complexity to that, but basically think of it like, there's this, giant blank stone in the middle of the town, and people can go and carve stuff into it like, Bob owes me $3, and whatever's carved in there won't change. And so if you can have all these, side agreements where people are, trading back and forth and doing all these things. Think of that as, Hemi as an L2. But then eventually the summary of that gets published to that, gets chiseled into that stone at the center of the town, and then nobody can change it and everyone can see it and reference it. I don't know if anyone else here wants to maybe add a better metaphor.
I'll try, since I have a 5-year-old who I have not explained this to.
Probably more qualified. You haven't explained it to him yet? Oh my God. Yeah,
according to my kids, I play in front of a computer all day, so that is their description of my job. So really, the one way to look at it is more than any other, cryptocurrency or just financial system in general, Bitcoin only moves forward and it's only additive. So you can only add new data to Bitcoin, and you're guaranteed that all the old stuff has followed the rules and stays that way forever. Pop mining is a way to put sort of a little summary of what's going on in Hemi onto Bitcoin. So we get Bitcoin's, perfect, always moving, and perfect's in quote because nothing's perfect, but we get Bitcoin's really good, always moving forward, always following the rules and additive at a much lower cost rather than doing it on Bitcoin, we just put our summaries on Bitcoin. And that sounds a lot like a, description of a L2 in general for Ethereum. And we do that too, but POP gets us the, super secure, always forward, always additive Bitcoin stuff at a, good price.
I think it's a great explanation. Then adding on to that a bit, because you mentioned the Bitcoin versus Ethereum side, Hemi is unique in that it's this dual chain L2. And so from different angles, it looks like different things. So from the Bitcoin side, it looks like it has, basically two components that interact with Bitcoin. It has the proof-of-proof mining that anchors it to Bitcoin, and then it has the HVM, which basically makes Bitcoin state available in the EVM, so you can program basically on top of Bitcoin in your dApps. And then on the Ethereum side, we're using that for DA. So basically what we did with the Hemi design is we said, we like Bitcoin, we like Ethereum. What are the best features of each of those chains, and how do we combine them together in a way that's powerful and synergizes, I hate to use that word, but synergizes the best of both worlds together in a really interesting, useful way. And so Bitcoin's greatest strength is security, and it's also the world's best, form of digital ownership of a guaranteed scarce asset where the protocol rules don't change very often. It's very secure and robust, moves like a glacier, and that's in a lot of ways a good thing. Ethereum moves fast. It has way more data available on its chain for doing stuff like DA, and it also has amazing programmability, and it has a great ecosystem of existing dApps with existing liquidity. And so Hemi was a way to thread the needle between those two chains and say, okay, we want Bitcoin security, we want to expose Bitcoin in the best way possible so people can build dApps that interact with Bitcoin in a very bare metal native way. But we want to do that in the context of Ethereum's programmability. We want to use Ethereum for DA because it's a lot more cost effective and scalable for that. And their roadmap is going to continue to scale that out far into the future. And we want to build it in a way that's not just using these items from Ethereum, but is also connecting to Ethereum as well with a native Ethereum tunnel. So you can do cross-chain calls from Ethereum to Hemi, from Hemi to Ethereum, move assets from Ethereum to Hemi in a very native protocol bridge tunnel system, and combine that with dApps built on top of HVM with that Bitcoin interoperability, the first one being the Bitcoin tunnel, that make that same sort of asset transfer between Bitcoin and Hemi possible. And then in the future, we'll make the transfer of Bitcoin assets from Bitcoin through Hemi to the Ethereum ecosystem possible, which is very interesting. So you get, when you're natively connected to two networks, you get a lot of new use cases and interesting stuff you can do because you're sitting between them instead of sitting on one of them and trying to connect to the other in some way that may involve centralized custodianship systems or some sort of trusted federation of relayers or whatever the case may be.
Or put very slightly differently, Hemi wants to be a full player in both Bitcoin and Ethereum, and therefore let things on either side be full players in the other, as opposed to usually you make some compromise on one side or the other side. And we don't want to make a compromise there. We want to be part of both sides and want to bring both sides together.
Yep, exactly. We also built the architecture in this is kind of a way out there, future maybe thing, but going from 1 to 2 L1s that an L2 connects to natively is much harder than going from 2 to 3. And so we're not going to bloat the Hemi protocol by saying, let's connect Hemi natively to all these chains. There's a lot of interoperability protocols you can use that, in the economic and security context needed for those make sense. But from the L3 perspective, and again, this isn't probably something that we're going to do internally, or if we do, it's very far in the future on the roadmap. But you can take that same architecture and you could have Hemi as the left leg and another chain as the right leg. And so you can use that as a way to bring those other chains into the ecosystem. They're not coming in through the Hemi base layer, but they're coming in through L3. So you could build a Hemi ecosystem L3 where the left leg again is connectivity to Hemi. That's the sort of L2 native connectivity in the way that you expect it. And then you could also add, Solana or Avalanche or whatever as that other leg. And obviously there's a lot of engineering that would go into that beyond just the architecture, but we built out the architecture in a way where you could do things like that and bring other ecosystems in a more direct native way through L3s versus using other interoperability protocols. So again, not on the roadmap right now, way far in the future, but interesting from a architecture and design perspective. All right, I feel like I derailed us quite a bit on that question. Why don't we get to the next one?
No, not at all. My takeaway was it's kind of like RoboCop, and I refuse to
Exactly.
explain that. Okay.
That was the simplification we were looking for.
Perfect. It's basically like RoboCop. You just got to think about it. Okay. I've been trying to build my own pop miner, and oh god, hold on. Sorry, the question just moved. I've been trying to build my own pop miner and encode the op_return. I can find all input values except the state root. Can the state root be added to the API block response like Ethereum-based explorers usually do?
That's a really good question. That's actually, as part of the daemon refactoring, that's one of the things that we're going to add to the opgeth RPC interface. So right now, the reason that's not available is because with the existing optimism infrastructure that we built on top of, you have, well, to take a step back, so the way chains like Ethereum or chains like Optimism work is they have separate layers for execution and consensus. So execution is your EVM. That's, okay, we know that this transaction is part of this block, and we know that the state machine of the execution environment, EVM, SVM, whatever, looks like this. Therefore, here's how we apply that transaction and what changes it makes to that state machine. And then you have the consensus layer that says, okay, here's the actual blocks and the transactions that are in them that are part of the canonical chain. So you have consensus, which is on Ethereum, for example, that's all the proof of stake miners and what chain that they're building on top of and voting on top of. And then you have the execution layer, which is once the consensus layer says, okay, here's the canonical chain, then it tells the execution layer, okay, these are the blocks and the transactions that you need to process so that your state reflects the latest consensus state that we agree that the chain is in with a consensus protocol. And so with Optimism, those two pieces are opgeth and opnode. So you have opgeth, that's your execution layer, which is geth, but with some changes to work as an L2. And then you have opnode, which is basically a brand new daemon that uses Optimism's consensus protocol, which at the current point is a centralized sequencer. That's where we're going to be adding in the Ethereum style proof of stake consensus protocol. But opnode determines what the current consensus of the chain is, both from L1DA and from pop data and from optimistic blocks. That term's a little overloaded here, but blocks that haven't gotten into DA and pop published yet, but that are created by the sequencer and they're tentatively added to the ledger. So it determines from all those data sources what the actual canonical, which means, correct in what, all of the data that we know about what could constitute the chain, the canonical chain, and then sends that information to opgeth. And part of that process, it uses something called the engine API, which is how the same way that a consensus client like Prism drives an execution engine like Geth in the Ethereum world, Opnode uses that same API, again with some modifications for L2 stuff, but that same engine API to drive the state of opgeth. And so the execution route that's used in pop mining, because pop mining is a consensus layer protocol, that's where that information is needed. That data with the current optimism structure doesn't get passed down to opgeth because it's not relevant to it. All opgeth cares about is the execution of the blocks and the transactions that are in those blocks that opnode tells it are correct. And so right now that's not available over the opgeth RPC, but that's something we're working on adding so that we could basically connect a pop miner directly to a geth RPC endpoint, which is like the same RPC endpoint you're using for MetaMask or that you're connecting an Explorer to. Explorer sometimes talk to opnode as well for some consensus stuff, but that's besides the point. But we are adding that state root and all the data needed to reconstruct the keystone, the L2 keystone, and the L2 abbreviated keystone that you need to actually get the raw data you need to encode in the op return. So right now that's only available from the BFG endpoint. And so to run your own stack, you need opnode, opgeth, BSS, and BFG all running so that you can connect to BFG and get that consensus information. We're moving the missing bits of that data over to the opgeth RPC so that everyone for pop mining can go through the same RPC you're using for MetaMask. And that'll make, among other things, that state root available. So in the works, and it's a great question.
All right. Does anyone? I'm just going to ask this after every question. Does anyone want to add on to that? Because I really don't know if anyone wants to add on to these. Okay. All right. We will move on to the next one. What will be the impact of migrating from BTC to Hemi tokens, if there's a plan to? Will the daily price of running PopMiner be the same? At the beginning, I liked the idea of running PopMiner on the web browser. I mean, everyone with some money could simply run Pop. Has the plans changed, or are we having a web PopMiner being constructed?
Can I take the web pop miner part first, and then I'll give Max the first half of it?
Yep, go for it.
Okay. So, as for the web pop miner, it was a really cool thing, especially doing it with the WASM and everything and all of the tech behind it. But if you were to look around in front of you, the two least secure things that most likely that are within reach of you are your cell phone and your web browser. The web browser is just a almost ridiculously large security surface and nearly unsecurable, or at least not to the level you'd like. So on mainnet, while it, for testnet, the web pop miner was a lot of fun and it's really cool. But on mainnet, we really don't want to, encourage people to do things that put their funds at risk. And putting your Bitcoin into the web browser that way there's a lot of danger there for not a lot of gain, especially since you don't need that many pop miners running on mainnet. And as is what it takes to run a pop miner, you can run it on a Raspberry Pi. You don't need any serious computing to do it. So the trade-offs for keeping the web pop miner on mainnet didn't seem entirely worthwhile overall. And that's why, for mainnet, we chose to focus on the CLI tool. And, yes, it was fun. The web pop miner was fun. It was an awesome thing. And WASM is pretty cool for letting you go from CLI tool to a web native tool. It just didn't seem like the right trade-off anymore. So for mainnet, we'd encourage the command line tool.
Yep, and to add on to that too, with the browser security side, most people who use anything crypto related in a browser use an extension, and those have their own security vulnerabilities. There was a recent thing where you could actually trick Chrome into, if somebody installed your malicious grammar editing plugin or whatever, it could detect that an application like MetaMask or something was open, and then close that extension, change its logo, impersonate MetaMask, and steal your decrypt password and stuff. So there's security issues with extensions as well, but those extensions work because they're more secure, and they're generally used because people are doing activities on a chain live, and so it's perfectly fine to have a procedure where they need to sign the transaction. So we thought about maybe adapting the web pop miner to use, integrate with Unisat or one of the other Bitcoin web browser extensions. But the issue with that is pop mining is something you want to, set and forget. You don't want every 5 minutes for a notification to pop up asking if you want to pop mine the next keystone, right? And so it just didn't make sense from a product perspective. The secure, or at least to the quality of web DApp thing, secure way to do it would be talking to an extension, which is not running inside your web page in the same way, not storing data in the browser that's accessible to other applications in the same way, but just the user flow for that did not make sense. So web pop miner, it's basically deprecated. It was a thing we wanted to do for testnet as kind of a technical proof of concept, like, hey, this is possible, and here's a cool demo of that. And it brought a lot of people in the early days in to be able to try out pop mining and see how it works and understand the mechanics. But it was really more of a testnet tech demo than a mainnet product.
And security is always a compromise. Like, no matter what, security is a compromise, and you just have to decide when is it a compromise. What level does it make sense? Like, yeah, I use MetaMask and Rabby and other web wallets like that because it is an acceptable compromise there. But for the pop miner, a combination of the compromise and as Max said, the just user flow for using it in an acceptable way kind of didn't fall on the right side of things.
And then the second part, something about migrating from Bitcoin to Hemi token. So I think I know where this question comes from. So pop mining for Hemi as the Hemi L2, that's always going to use Bitcoin. We are going to be changing the payout algorithm soon in pre-TGE mainnet for the final pop payouts algorithm that'll be used post-TGE. We can talk a bit about that if we have time, but you're always going to be, whatever the payout algorithm is, you're always going to be spending Bitcoin as the input because you have to pay a transaction fee on the Bitcoin network to publish the data that you're taking from Hemi and publishing to Bitcoin so that Hemi can inherit Bitcoin security. So that's always going to be a Bitcoin fee payment. However, once we get to Chain Builder with L3s, those L3s are publishing data to the L2. So in that case, those L3 pop miners would be paying in Hemi tokens to publish data from their L3 down to Hemi's L2. And then there'd be another set of pop miners who are paying Bitcoin to publish those aggregated state roots basically to Bitcoin that represent Hemi state and the state of all those L3s that were pop published to it. So pop mining, the Hemi chain itself, where you get rewards in the Hemi token, that's always going to be Bitcoin as the input. But eventually with Chain Builder with the L3 ecosystem, pop miners for those L3s would be paying Hemi tokens and receiving L3 tokens. Or some other security budget that the L3 provides. There's different ways to do it, but that's the macro.
Awesome. Next question is, why centralize Keystone broadcasting via a private BFG?
Good question. That's a stopgap. So we're running the infrastructure that people need to use to run a pop miner. With what we have right now for running a node, you could run the entire stack locally. So you could run your own Ethereum node, your own Bitcoin node, your own op node, BSS, BFG, opgeth, and you could run that entire stack. To do all that, it takes about 6 terabytes, and you need a semi-decent machine. But if you did that, you would have your own BFG endpoint that you can broadcast to that basically sends that transaction to electors. That's another part of the stack, and then sends that to the Bitcoin full node. And that's part of why we're working on simplifying the stack, so people don't have to run all of that to get their own private BFG endpoint. They could just run, BFG and connect it to a TBC instance, or BFG and connect it to a Bitcoin D node that they're running locally or whatever, and not need the rest of that stack for the actual Bitcoin broadcast side of it. So that's part of the rework, but it is possible right now. It's just a little heavy-handed. If you do want to run all the components of the stack and have your own BFG endpoint, that's also going to come with your own opgeth and your own op node endpoint as well. So it's basically every single endpoint that we host to make available. You could run that entire stack locally and run your own version of that if you wanted.
And if you do choose to run all of that stuff yourself, I want to hear from you because, that we can always improve that process. But also, sort of going off what Max said, decentralization is not a checkbox. I'm not going to say it's a journey because I hate when people say anything's a journey, but, it's a process. It takes time and, you start out, just like initially all of the commits in our repos were by Hemi Labs people, and slowly we've had PRs from outside parties. It's the same thing with bits of infrastructure like that. It starts out because we wrote it, we run everything, but, decentralization takes time and we're all part of it.
Awesome. Thank you very much, guys. Let's see. We're moving on to the other section. Why is my screen not scrolling? Oh, there we go. How do I launch my own meme token on the Hemi network?
Hemi's a EVM chain. With HVM is basically EVM plus Bitcoin components, but if you don't care about those for a particular use case, they don't matter. So just like you could launch a meme coin in any other, Ethereum or Optimism, Arbitrum, ZK Sync, whatever, same exact process for launching on Hemi. You basically get an ERC20 contract, make whatever changes to it you want to make, whether that be, the decimals, obviously the name, the ticker, the float of it, how it gets distributed if you need to do something custom there, and then just launch that contract. You can use, tools like Hardhat or Foundry. You can also use the Remix web IDE and connect that to MetaMask as an injected RPC provider. So if you have MetaMask or Rabi Wallet or one of those connected to a Hemi RPC endpoint, you can connect those into Remix and deploy a contract easily from there. And so the answer is basically same as for any other EVM chain. And for tooling, everything supports and works with Hemi, although as, one of many chains. They're not all supported directly by, default configurations in the tool. So depending on the tool, you do have to put in information about the Hemi network, an RPC endpoint, chain ID, stuff like that to get the tool to be able to actually connect to the Hemi network, send the right stuff, be able to verify a contract with a block scout, Explorer API if you want the contract verifiable, which is obviously heavily recommended for anything anyone's deploying. But in general, same process as any other EVM chain.
All right. I want to preface this with, I love you all, but we only have 5 minutes. So please keep that in mind when I ask this question, because we've met. How does the HVM work, and what features do you have planned? Oh, God.
All right, rapid fire. So HVM, you can think of it as the merger of the EVM that everyone knows and loves, and all the tooling, all of the infrastructure, all of the existing code, all of the work that's been done into making the EVM robust and fixing bugs, all of that. So all of that from Ethereum's amazing development work on the EVM since 2014, 2015, combined with full visibility into what's happening on Bitcoin at a smart contract level. And so HVM, what we did is we took the standard EVM, backwards compatible with anything you want to use the EVM for, and we added what are called precompiles, which are ways that you can basically step outside of the execution of the EVM. You can think of it kind of like an opcode in some sense. It's different in that, opcodes are doing things, they're manipulating registers directly. So, they're saying, hey, move what's in register 1 to what's in register 2 and add it to what's in register 3, right? That's an opcode. Whereas precompiles, similar concept. It's a very low level thing that's a part of the execution environment, but they can do a little bit more complicated stuff. And so in the Ethereum landscape, precompiles have been used primarily for things like accelerating cryptographic functions, where if you were to, say, compile the algorithm for calculating a SHA-256D hash or, a curve pairing for a ZK verification or whatever, those would be very expensive if you were to just write out the algorithm in Solidity and compile it and run it in Solidity with Solidity's opcodes. But you can use precompiles to basically leverage, Go code or Rust code, whatever it is for the implementation you're using, but they basically have those algorithms implemented natively in the execution environment. So you can call SHA-256 and pass it whatever you want to hash, and it returns the hash, and it's very cheap to use. So we use that same methodology basically to let the EVM call outside of itself to the Bitcoin full node that's running inside the EVM. So we have a daemon we call TBC, or Tiny Bitcoin, which is a full Bitcoin node that communicates with other Bitcoin nodes over Bitcoin's peer-to-peer network. And its state is driven deterministically by the current consensus state of Hemi. So if you're on Hemi block 1000, or say you had 3 nodes that are all on Hemi block 1000, they're all going to have a TBC node that has the exact same state, which you need because any smart contract running on one node needs to run deterministically on all of the nodes on the network. And so the current consensus state of Hemi drives the consensus state of TBC. TBC is a fully indexed Bitcoin node, which means you can ask stuff about the UTXO table. You can ask stuff about any transaction on the network. So if you look at like Bitcoin D, there's no RPC. Well, there is an RPC request, but it takes like 30 seconds to run to look for something in the UTXO table. TBC is indexed, so all that data is already available to be easily queried and pulled out. And so these precompiles are basically a way for your smart contract to step outside the EVM in a sense and talk directly to that deterministic, fully indexed Bitcoin node that's running inside of the EVM in a sense, and run a query on it. So you can say, get me the latest Bitcoin block header, or get me, I want to know whether this UTXO is spent or not because it's relevant to my custodianship application I'm building, or, does this transaction exist in the chain? And so any questions you have about the Bitcoin state, you can pull out through those precompiles and then use in your smart contract. Now, those precompiles, like I said, those are low level. So we have another layer called the Hemi Bitcoin Kit, and that's a smart contract library, and it also includes a VM extension if you're building like front ends especially. But the main component for a Solidity developer there is that Hemi Bitcoin Kit contract, and that abstracts away a lot of common queries. So if you wanted to say, get a transaction and you only care about this information from it, like you only want the outputs of this transaction, it'll go and construct the low-level HVM precompile call it'll send that to it'll call the precompile, it'll get the data back, it'll parse it for you into nice structures that are easy to use. So instead of a blob of serialized data coming back, you get this nice struct, and you can say, okay, give me output 2 from that, and I want to look at the script sig from it or whatever. Script sig would be an input, but you get the point. And so HVM low level, you're stepping outside the EVM in a sense. It's still all within the EVM, but it's not a direct opcode to query data from that fully indexed TBC full node or Bitcoin full node, which the implementation is TBC. Get that data back, use it in your smart contract, and so you can use that to build all kinds of Bitcoin-aware applications. And so, unlike an Ethereum L2, you can't do a direct smart contract call to Bitcoin because Bitcoin's architecture doesn't support it. But by knowing what's happening on Bitcoin, you can do you can build DApps that respond to that. So say you wanted to build a non-custodial DEX, you could write smart contracts where one user posts USDC as collateral for the trade they want to make. It matches them with a seller who wants to sell Bitcoin for that USDC. That USDC goes into escrow, and then that user has to deliver that Bitcoin to the person who put up collateral's Bitcoin address, and your smart contract can monitor the Bitcoin state to make sure that that transaction was completed successfully, and then release the collateral to the Bitcoin seller. So there's all kinds of cool stuff you can build with HVM. You could build a Bitcoin transaction accelerator, so you could have people pay USDC or ETH or in the future, Hemi token or whatever to accelerate a transaction, and then whatever Bitcoin miner puts in their Bitcoin block, that acceleration fee goes to them, to their, an address derived from what they have in their Coinbase transaction or that they registered or whatever. You can build non-custodial lending protocols. So you put up, in one direction, you put up collateral in USDC, and you can borrow Bitcoin natively on the Bitcoin network. It never has to be tunneled over. And so it opens up a new design space for how to build Bitcoin DApps in Solidity with all the existing Ethereum tooling that interact with Bitcoin in interesting ways. And so the most clear example of that today is the Bitcoin tunnel system, the V1 that we've introduced. That is all built on top of HVM and HBK. So that entire thing is just smart contracts that run on top of the Hemi HVM, and they use that Bitcoin awareness that they can pull out of HVM to basically monitor vault custodianship addresses, monitor transaction sweeps that vault operators are supposed to do, all of those things. And that's all made available natively in the EVM. And so if you compare that to other ways of getting Bitcoin awareness in an EVM or whatever, the most popular one is something called Bitcoin header relay, which is very limited because all you're doing is relaying Bitcoin headers, and then you can prove a transaction exists in that chain based on providing a Merkle path, which authenticates a certain transaction to the state root, and you still got to manage all the parsing yourself. And the more important part is there's a big part of Bitcoin's state machine that is not authenticated to Bitcoin headers. And so even if you know the state of Bitcoin, there's no concise way to prove that a certain UTXO is not spent or something of that nature, because that data is not authenticated to Bitcoin in any way. And so with something like HVM, the entire UTXO state is part of that indexer. It's built deterministically as part of Hemi's state transition function, so you can access all of that data directly. So you don't need anyone to relay it. You don't need an oracle. That's the current way of getting UTXO information, is using a trusted oracle in other solutions. On Hemi, all that data, everything about the Bitcoin state machine is 100% trustworthy as the state of an EVM on an EVM chain is, and you can talk to that directly and get any data you need without users having to relay it into your system with some sort of long, expensive cryptographic proof that's hard to validate and expensive to compute. All of that, it's easy. Whatever you want to know about Bitcoin, your smart contract can directly access it. If we have another 10 minutes, there's more to say, but
I was going to say one really quick, if I could add one quick thing to that. Max, you said a whole bunch of times that it's TBC being deterministic, and it's probably not immediately clear why that's important, because we think, of course, that things are deterministic, great. But that's actually a much bigger deal than it sounds, because you have to remember blockchains like Bitcoin are all around the idea of being eventually consistent, meaning, if I ask two different Bitcoin nodes things, they eventually have to agree, but at this second, they don't always have to agree, and everyone has their own mempool and all sorts of other things. And so to make sure that TBC says that at this state in Hemi, this is the state of things, and that's an important detail. It's not just, it sounds like a throwaway word, but it's not. It's actually a really big deal.
Yeah, that was a lot of the engineering work, was making it deterministic. It's easy to, not easy, but you could put a Bitcoin full node inside an EVM that just connects to the Bitcoin network and processes whatever information it hears from the Bitcoin network. But then the problem is when two nodes process a EVM transaction or an HVM transaction that do a HVM precompile call, if they get different answers, they're going to do different things in that execution environment. Their states are going to diverge and you're going to have a network fork. And so making that Bitcoin node deterministic and saying, okay, whenever anything's running in any EVM anywhere at any point in the L2 chain, it's going to have the same view of this giant 700 gigabyte fully indexed Bitcoin state that every other node doing that same transaction with that same EVM state is going to get. That is hard to design. That's a lot of the engineering that went into HVM was building that deterministic TBC. And I wish we had Marco on to talk more about it. Joshua and Antonio have also done a lot of work on TBC as well. But that is, it's not a throwaway word by any means. That is a very important part and probably the hardest challenge to solve when embedding a Bitcoin node inside of another execution environment.
Yeah, and it really makes it's what makes it useful rather than, just something that relies on oracles or some other, junk like that. It means you really do get to see Bitcoin and not just some, garbage version of it that, maybe right, may not.
Yep. Yeah. The same state, the same way that a smart contract can trust the state of basically itself or another smart contract on the same EVM, that same level of trust and no need for oracles, relayers, whatever, applies equally to anything that you're reading about Bitcoin on the Hemi network. And so that's not to do a competitor comparison, but nobody else who's building any sort of Bitcoin, smart contract programmability system is providing all of that data in that trust model, which makes it makes Hemi the best place to launch any sort of truly non-custodial DApp that interacts directly with, native Bitcoin on the Bitcoin network, BRC20s, runes, ordinals, even without full index meta protocol support. There's things you can do with those protocols using UTXO awareness. So it is, if you want to build Bitcoin aware, Bitcoin native DApps, Hemi's the place to do it because you get all of the data with none of the compromises of any of the other solutions.
And you should join the builders channel if you're one of the people who wants to do that kind of building.
Yep, absolutely. All right, cool. I think we do have to wrap up. Unfortunately, we have another meeting to jump to. I'd love to do this again in the near future, maybe get some of the other people from the protocol engineering team who couldn't make it today, get them on and part of the discussion as well. And we have, I think there were a couple questions we didn't get to, and I also do want one of these AMAs to dive deeper into the BitVM design and some of the stuff that we're doing there that is unique versus the other BitVM designs and how Hemi's architecture supports doing that in a more robust and secure way than a lot of the other solutions on the market. And so I think we'll stop it here and sign off, but definitely looking forward to doing one of these again and deep diving into some other topics.
Yeah, this was great, guys. I would love to do more of these. We had great attendance. The questions were awesome. The answers were great. Yeah, that would be fantastic. We do have to jump to another meeting, though, so I'm just going to pass it back to the team for final sign-offs. But thank you all so much for attending. We'll see you at Midweek with Max and hopefully a lot more AMAs with the engineering teams.
Awesome. Thanks, everyone, for coming out. I really appreciate the... I'm surprised how many people wanted to listen to us ramble about tech details, so that's great to see. And anyone who wants to build something on Hemi, especially if you're interested in using HVM and want to understand it better, ask questions, the incoming builders chat is going to be the place to do that. A lot of us engineers will be, I'm not on Discord very much, but I will be in that channel answering. If you ask an HVM question, there's probably like a bat signal that goes out or something. We'll figure it out. But definitely looking forward to anyone who wants to build using what we're building at Hemi. Looking forward to seeing all of you there. And thanks to the protocol engineering team who was able to make it out today and join the conversation. And we will see you next week.
Yeah, thanks, everyone.
Thank you.
Take care.